Unit 3, Day 5. Rational exponents. Again, I keep writing rational this way to sort of emphasize what it means to be rational. It means there's a ratio in there. So a rational exponent. So an exponent, that's a ratio. So something like a to the m over n. I don't know why we pick m and n when they sound so much alike. M and n. One of those is a power. One of those is the root. Do you remember which one is which? One of those is a power.
The top one is the power, and then it's like so 1, like 49 to the power 1 square root 2. That's just the one that I'm looking at.
Okay. Yes. The top number is the power. The bottom number is the root. I think Mr. Rainey was gone before any of y'all had a chance to have him, but he liked doing this silly little picture. That's a terrible looking flower. But you get the idea. The flower power grows on top, and the roots grow underneath. Yeah. And he would do a little silly like flower power on top, roots underneath. Flower power on top, roots underneath. Dumb, silly, but maybe helps remember the power's on top, the roots underneath. Another way to write that then is that the power, a to the m, but the nth root. Which, this is the same thing as the nth root raised to the m. Either one of those are the same. There's not like an order of operations because both of those are exponents. So you could do either one of them first and you get the same thing. It's like this one is exponent first, this one is root first. Yes, sir?
Are those both ends on the left?
Oh, that should be an n, sorry. So you can evaluate either way, but usually this one's easier.
So this one is power first?
Well, that would be root first and then do the power. It's usually easier to root first because you get a smaller number. If you power first, then you might get some huge number and then you're trying to find the square root of some massive number. So it's easier, usually easier to take the root first and then the power. So 25 to the 1/2. Start with really easy one there. So that's the square root of 25 to the first. So the square root of 25 is 5. Okay, but let's go a little bit deeper than that. 25 to the 3/2. So that's the square root of 25. I'm not going to put the 2 there because that's not needed if it's a 2. And then cubed. So the square root of 25 is 5. And 5 cubed, 5 times 5 is 25, times 5 is 125. This is a good one to demonstrate why we like to do the root first. Because if you do the power first, so if you want to take the cube of 25 and then square root it, I mean, obviously the answer has got to be 125, but I don't know what 25 cubed is. And even if I did, I doubt I'd be able to take the square root of it to get to 125. So use the bottom first and then the top. That sort of still fits with the flower analogy, right? The roots grow first, and then the flower blooms later. So root first. 49 over 16 all to the 1/2. 49 over 16 all to the 1/2. Gregory, what do you think the answer is?
I don't know.
I wasn't sure if that was a serious sigh or a sarcastic sigh.
7 over 2.
7 over
4.
4. Ava was about to give you a high five for a wrong answer.
Yeah, come on, Ava.
Square root of 49 over the square root of 16, so 7 over 4. So you can handle them, the top and the bottom, separately. Like some people get stuck looking at 49 over 16. You're like, I don't know what to do with that. I don't know what the square root of 49 over 16 is. Well, you do know the square root of 49 and the square root of 16, so you can handle them separately. (81 to the 3/4). 81 to the 3/4. Well, let's rewrite it as a root and power problem. So the 4th root of 81 cubed. 4th root of 81. Well, if I'm giving you these problems without a calculator, it's probably going to be an integer. So can you figure out what times itself 3 times gets you to 81? I mean, 2 4 times is 16. 3 4 times is 9 times 9 is 81. So the 4th root of 81 is 3, and then 3 cubed is 27. Do you remember what a negative does? 81 to the negative 1/2? Flips it. Flips what? The base or the exponent? Uh-oh.
What's the base?
The base is 81, the exponent's 1/2.
Oh, okay, so it makes it 1.
So it flips the base, so 1 over 81 to the 1/2, which is 1 over the square root of 81, which is 1/9. That's a place where I don't really expect you to show all of those. Some of you are going to look at that and just in your head think, okay, flip it over, take the square root, 1/9. This is one where there's often not a whole lot of work to show. Just dangerous for some of you because you just copy the answers, and I don't know that you just copy the answers, and then I guess we'll find out on test day. 8 over 27 to the negative 2/3. Okay, that's as hard as they can get, because we got a fraction, and then the exponent has a negative number, a numerator, and a denominator. So there's like 4 things trying to go on here. So slow down on this one. Don't do all of this one in your head, Gregory. Sorry, that's for you. So what do you want to do first? I would flip the fraction. I like that answer. So let's make that 27 over 8 to the 2/3. And I don't really like looking at 27 over 8 because I don't know what that is, but we can handle them separately. So 27 to the 2/3 over 8 to the 2/3. So that's the cube root of 27, root first and then squared. So that'd be 3 squared is 9. And in the bottom, kind of the same process, the cube root of 8 squared. Cube root of 8 is 2, 2 squared is 4. Again, I don't really expect you to show all of those steps. I would expect you to show some steps on that one. Just because there's so many things that's a good one where if you try to do everything in your head, it might not work out for you. Let's do an equation. And because you guys are good, we'll just do two equations, both of them kind of crazy, and we'll figure if you can do these, you can do anything. 1 plus parentheses 2x plus 100 to the 2/3 equals 26. So I'm trying to just peel off the layers to get to x by itself. So what should we do first?
You should
Subtract the... I wouldn't subtract
set it all to 0, right?
I would not on this one. I would subtract 1 to get it equal to 25. 2x plus 100 to the 2/3 equals 25. Right, and we haven't done one like this before, but do you remember how you can undo an exponent of 2/3? Like what would counter that? When you do a power to a power, what's the rule when you do a power to a power? If I have x squared to the 5th, what's that equal to? X to the 10th, because you multiply the powers. So I'd like to put this to a power so that when I multiply them, they cancel each other out, and I'm back to just 2x plus 100. So what power, just looking at the power now, what number times 2/3 would get me to 1? What number times 2/3 would get me to 1? 3/2. So let's raise each side to the 3/2. So on the left, it looks terrible because you got 2/3, 3/2, but 2/3 times 3/2 is 1, so you're back to just 2x plus 100. On the right, you got a little work to do there. The square root of 25 cubed. 5 cubed is 125. And finally, we're down to like an algebra 1 equation. 2x equals 25, x equals 25 over 2. But the key step on that one was raising it to a power that would cancel out the power that we're trying to get rid of. So raise it to the reciprocal, because power to a power you multiply. One more. 11 plus x to the 2/5 all over 2 equals 10. It's frustrating how many people miss the very first step on this. Having said that, multiply by 2. Like, just fix that denominator and be done with that. So multiply both sides by 2. What happens on the left-hand side? They cancel. That was the whole point of multiplying by 2. 11 plus x to the 2/5 equals 20. So x to the 2/5 equals 9. What next? This would be the new thing for today. What do I raise both sides to? What power do I want to use? 5 over 2. And again, it always looks awful when you're on the side that you're trying to fix. And if you didn't know what you were doing, like someone might walk in and think, wow, exponents of 2/5 and 5/2, that's impossible. And you would assure them that no, that's good because they cancel each other out. And then the square root of 9 to the 5th, 3 to the 5th. Well, let's see here. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. times 3 is 243. All right, that's it for today. Unit 3 worksheet next. I think it's worksheet 5. Yep. And a lot of those are really straightforward. There's a few equations toward the end, but most of that is cruise through and be done before you leave.